Hi, my name is Austin Rosen and I'm teaching high school chemistry. And this topic we're going to be talking about is going to be based off atomic theory, right? And we're going to go to our topic of the chemistry of fireworks, right? We're going to be thinking about, well, how is it that fireworks produce so many different colors? So I'm sure all of you, right, we see fireworks often, such as 4th of July. And, it's really quite fascinating how it produces colors. And that's what we're going to be looking at for this presentation, right? So the first thing we need to talk about is that it's very important to state that fireworks are made up of many different elements, right? As we all know, everything is made up of matter, right? Everything that exists in the universe is matter, and all matter is made up of elements, and fireworks are no exception. And we know all elements are shown in the periodic table, right? So now it's very important to talk about that when an element is heated up. So when we're going to be heating up an element, like in the case of firework, right, we heat the elements up, it's going to produce a certain color of light. And then there's a video here that's going to show that. So let me go to this video. I think it's just control click. Here we go. And I got to say that there's no audio for this video, so I'm going to be just talking over it. Right. So what we're doing is that I'm starting off having a specific element, right? And first, this is going to be sodium. And I'm going to be getting a little bit of a sodium sample. And then we got a little Bunsen burner with the flame going. And then we're going to be lighting it up and seeing what color it produces. So let's see. So we can see that, when I have the sodium, right, heating up from the Bunsen burner, it's going to be giving like a reddish flame, right, or orange. And I'm going to write that color on the board, right? This is known as the flame test. This is a demonstration as it shows as the colors released by elements when heated. And first we did sodium, we put it to yellow color. Now I'm going to be showing the next batch of elements. So we're going to be going to potassium now, right? And we're going to be showing this through a little bit of a spray, right? I have right here, this is potassium. So here I go spraying the potassium, and we're going to see what color it produces. It looks like it's going to produce a pinkish color. It's going to be producing a pinkish color. Looks quite nice. And that's what I'm going to write on the board. This is taking me a little bit of a moment, but so I'm writing down violet. See, I'm writing down violet, lavender. All right, which is, close to pink, right? Violet. So we'll say violet. Now we're going to boron, right? That's the next element I'm going to be heating up. Have our little boron sample, and it's going to be showing a green flame. Now a green flame is going to be showing, as we were able to see there. And now I'm going to be writing in the board, boron is giving a green flame. Or lime, right? Close enough. Now let's move on to copper. Let's see what happens when we heat up copper, what color it's going to produce. Color flame. And then, yeah, we got a little bit of our copper sample there. Right, this is our substance that contains copper, and this is what we'll be heating up. And looks like it's going to be green, right? Or I believe so. Let's see what color it produces. Going to speed it up a little bit. So it's going to be a blue-green. So for these last ones, I might speed up just a little bit because we're kind of getting the idea, right? Each element's going to produce a certain color. So now we have calcium. I'm going to be heating this up. Now we got an orange color, right? Looks quite nice. Orange there. And I'm going to be Walking over to write that on the board. Orange. Yeah, I'm kind of blocking the way a little bit, but I think you can all see it. Right, this is going to be our new substance. I believe this is, let me go back, cobalt. This is going to be cobalt. Let's go and see what happens when we heat it up, what color it produces. Okay, now we got like quite an orange color there, cobalt. So then we got like just the last couple of elements to show. But for cobalt, it's going to be pale yellow, I wrote there, which it did look so. Let's try out strontium. That's what SR stands for. SR stands for strontium. You can see our sample strontium right there on that dish. I'm going to heat it up. Ooh, now we're getting quite a fiery red there, passion red. Let's see what it is that I wrote for strontium. Ruby red. So I think I did write passion, but we just have ruby red here. Ruby red. Now we got lithium. Oh, you know, I think this is sulfur actually. Let me go back just to see. Yeah, this one might be sulfur. We'll see which one I wrote down. But this one is really cool because you're gonna like see it kind of dripping. So yeah, this I got from a sample containing a bunch of sulfur. It's gonna be heating up. It's gonna be kind of like purplish. You can see. Yeah, and then it's gonna kind of start dripping. So we put it just right on the sink, right? And we show it dripping. Yeah, just oozing out. So that's pretty cool for sure. So I think we actually already did lithium. It was the one before. That was magenta, right? Lithium was really similar, but then we have sulfur, which was blue, right? Blue purplish. And then we got like a little chart right here, right? This shows the flame test. And that's pretty much going to be the basis of our video. So let's go back to our PowerPoint slide now, right? So the idea is that when we have fireworks, right, when a firework gives a certain color, that's because it has a certain element, just as I was showing with that video. So when we have red fireworks, we can see it's strontium, green barium, pinkish lithium, yellowish sodium, bluish copper, and then kind of like pale or beige would be calcium, right? But we really have to think about like, why is it that this happens? Like, how is it that like a certain element when heated up gives a certain color of light? Like, why is that? That's what we're going to be looking at for the rest of this lesson, right? And the key to understand this is to think about atomic orbitals, right? Remember we have learned before about how electrons orbit around the nucleus, and based off the distance they are, those are known as orbitals, kind of similar to planets orbiting around the sun. So we're going to have different, right, energy orbitals. We can see here, this is the second orbital and then the third. And then when we absorb energy, so when a substance is heat up, the electrons are going to go from a lower to higher energy state. This is known as absorption. But then when you have electrons go from a higher to a lower, as we can see here on B, that's going to be emitting energy. That's going to be known as emission. And this little diagram here shows this in a little more detail, right? It's kind of like a nice little comic type diagram, but it's saying, hey, we have a happy hydrogen atom with a single electron in its lowest electron shell, but there are other shells available. And with just the right kick, so that kick would be that energy coming in, we can go up to this higher electron shell, but it's not necessarily happy, it's rather excited, right? So that's why when it goes up in energy state, it's going to be called excited state, right? And then we start off with ground state. And then as soon as it gets the chance to release that extra energy, right? Because eventually that extra energy is going to be released, it goes back down to its ground state, right? And this is kind of and that energy is being released, as we can see here, as it's going back down. Right. And so it's very important to note that when we have electrons go from the excited state to the ground state, the energy that it's going to be releasing is going to be in the form of photons. And it's these photons that is how we observe light. So anytime we see light from anywhere, right, everywhere around us, those are photons being emitted from, the energy that those particles contain in them and then release, right? Those are going to be photons. And here we're going to be, we're going to be showing here that based off the amount of orbitals that those electrons travel or go down, that's going to determine the specific color. So we can see here that, when we start with excited state 6 and go down to 2, we're going down 4 states, orbitals, that's going to give the color violet. When we go down 3 orbitals, it's going to give blue. 2 orbitals, it's going to give green, and 1 orbital, it's just going to give red. So it's very important to state that the color a photon emits, the specific color, is entirely dependent on the number of orbitals that the electron travels back down. And it's also very important to state that each element, so all of our elements in the periodic table, whether it's sodium or strontium or copper, right? The electrons are always going to go down, travel back down by a specific number. And that's why when we heat, right, let's say a certain element up, that's why it's always going to give that exact same color. And this is why fireworks produce a specific color, right? This is how the chemistry of fireworks work. And, for next lesson, we're going to go into more detail about how is it that, these colors behave in the form of waves, right? Energy. So anyways, you did a great job, everyone.